Hello everyone, Professor C is back at it again with Gus. And this may be our final bonus videos. I don't think we have bonus videos for final thing. So I won't need you anymore, Gus. And besides this one time, sorry Gus. He's okay. I had to let out my anger. Anyway, we'll try to go quick today, because I notice I always take forever with these. I apologize. We have today, this is question 6 for exam 4. And the question gives us the following equation. We're using the green marker. There's a black marker. It's kind of dead. Hopefully the green one will be able to see. If it's not, I'll switch to the black marker. So our given equation is 2a plus b plus c turns into products. You can see that? Kind of. Well, I'm gonna write it in black. Also, I'll write a bit lower. I think the glare is making it harder to see. Oh. Blah, blah. Sorry, that sounds no faster. Alright, set that. Ooh. Can you see that? Yeah, you probably can. The 2a plus b plus c gives us products. And basically, the problem's asking for 4 different questions. The first question is, what is the rate law? I actually read this wrong when I was solving it on my own. Oops, I've not never said I'm not the smartest person. I apologize. Products. Okay, the first question is, what is the rate law? Rate law is the rate of this entire reaction. The rate of this entire reaction is equal to sorry. They also gave you some other things. So we were given that for A is a first order reaction, for B is a second order reaction, and C is a zero order reaction. And we're going to use that to solve for rate law. So rate law is equal to K times the constant, and for the rest of it, it's going to be rate law is equal to K times concentration of A, and that's times concentration of B, and multiplied by concentration of C. Because rate is dependent on concentration. However, it's only dependent on concentration depending on the type of reaction it is. For example, what order reaction it is. For example, we're told that for A, it's a first order reaction. So you write a 1 above the concentration. You don't have to, because it's implied, but you get the idea. For B, since it's a second order reaction, you write a 2 to square it. And C is a zero order reaction. Take a guess what it is. That's right, it's 0. Basically, the explanation is rate is not dependent on the concentration of C. So, like, if there's like 20 moles, if C has like a molarity of like 20, the rate won't change regardless if it's like 20 or 10 for C. But like if the concentration of B is like reduced by a lot, the rate is decreased by a lot. And if the concentration of B is increased by a lot, the rate will decrease by a lot. And for A, similar thing, rate increases proportional to how much A is increased. So if A is multiplied by 5, rate will increase by 5. If A is divided by 5, rate will increase by 5. If we're going to use the answer to the following questions. So the second part of the question is, what happens if concentration A is doubled? Well, I just addressed that. Since the rate is proportional to okay, sorry. So the rate is increased or decreased corresponding to if A is increased or decreased proportionally. So if A is doubled, that means rate would be doubled. So for second part of the question, I'm sorry about the marker. Oh my. I think it died. Oh? A's doubled. I'm just gonna use a new marker. I think the black marker gave out on me. I apologize. So I'm going off a bit of tangent. But basically, the concentration of A is doubled, rate is doubled. A is not at A. Sorry guys, maybe I should have beaten you. Anyway, for part 3, it asks what happens if concentration of B is tripled. Yeah. So we already addressed that earlier. So if concentration of B is increased by a lot, concentration of the rate will decrease by a lot, and concentration of B is decreased by a lot, the rate will decrease by a lot. And we can tell exactly how much rate is decreased or increased by the square. So just think about it. If we have 1 molar of B, right? 1 m of B. I'll write it down here. 1 m of B. Right? If we triple this and make it 3m, what happens to the rate? Well, rate law is equivalent to concentration of B squared, right? So if we square that 3, we get 9. So basically, if concentration of B is tripled, rate will be tripled as well. I mean, if concentration of B is tripled, we square it 3, which becomes 9. Therefore, the rate is multiplied by a magnitude of 9. I'll repeat everything again. Make sure you read it. Not really. Maybe. Probably. I'll move the computer can. Or I'll move it right now. Apologize. You told me it says not to move the camera. But this should be better. Sorry. And for part 4 of the question, it asks if the concentration of A is halved, if the concentration of B is doubled, and the concentration of C is doubled, what happens to the rate? Well, for C, it's obvious. It doesn't matter. Since C is a zero-order reaction, whatever the concentration of C is doesn't affect rate at all. So we can ignore C. What matters is A and B. Well, since A is halved, remember, as I said earlier, if you recall, I said the concentration of A, if it gets increased or decreased, rate is increased or decreased proportionally. So if A is halved, rate will be halved. And for B, remember, since it's squared, we have, since B is squared, if we had, I don't know, 1 molar of B, and we increased it to 2 molar of B, doubled it, then you square that, you get 4. So rate would be increased by a magnitude of 4 if we double B, correct? Yes. Therefore, since that means rate's going to be both multiplied by 4 and multiplied by 1/2. So rate is equal to and if rate is double is increased by a magnitude of, it's multiplied by a magnitude of 4 and multiplied by a magnitude of 1/2, that just means it's multiplied by a magnitude of 2. Yeah, so reaction is doubled.